Today's lesson is evaluate inverse trigonometric functions. So my learning goal for today is I can evaluate inverse trigonometric functions by stating the angle for the value of the given ratio. Okay, to evaluate the values of the inverse trigonometric function, the range of the principal branch of each trigonometric function must be known. The reason we're looking for the range is it is the restricted domain. So in the previous lesson, we talked about how do we find the arc cosine, and we are looking at cosine here, and we were restricting cosine here, switching x and y, and this is where I got my arc cosine from. And I know the arc cosine, these are quadrants 1 and 2 on the unit circle. So quadrants 1 and 2. So this is 0, pi over 2 to pi. So my range, because I'm going from here to here, is from 0 to pi. So I'm talking about quadrant 1 and quadrant 2. For arcsine and arctangent, so for sine, here is sine. And we restricted the sine principal branch to here. So that was the restricted domain, which is the range of the arc sine. So this is going from minus pi over 2 to positive pi over 2. And when we were talking about arctangent, we said arctangent was this. So this was also minus pi over 2 to pi over 2. So my range for arcsine and arctangent are the same. They are minus pi over 2 to pi over 2. So thinking about this on the unit circle, this is minus pi over 2, and this is pi over 2 here. So I'm talking about quadrants 1 and 4. Okay, so quadrants 1 and quadrants 4. Okay, so very quickly, I'd like you to fill in sine, cosine, and tangent of the first quadrant of the unit circle. You should fill these out very quickly. So at 90 degrees, this is 0 and 1. So I'm kind of thinking about the coordinates here. So putting these in, the simple way is just to do 1, 2, 3, 1, 2, 3, all over 2. And then I'm going to take the square roots of the numerators, and the square root of 1 is 1. So I just leave that alone. And at 0, this is 1, 0. And tangent is y divided by x. So this is y divided by x. So cosine is x, tangent is y. I'm sorry, cosine is x, sine is y, and tangent is y divided by x. Okay, so y divided by x, 1 divided by 0 is undefined. Square root of 3 over 2 divided by a half is the square root of 3. Square root of 2 divided by 2 divided by the square root of 2 divided by 2 is 1. 1/2 divided by the square root of 3 divided by 2 is 1 over the square root of 3, or the square root of 3 over 3. And 0 divided by 1 is 0. We should be able to make this table pretty quick now. All right, so we're going to use this table to do the assignment. All right. So when I am asking what is the arc sine of a half, I want to know what's the angle. Anytime I'm using sine inverse or arc sine, I'm asking for what is the angle whose sine equals a half. And I'm going to do that in the quadrant of the principal branch. Okay, so let's find the exact radian values. So I want these in radians. No decimals. And make sure we're in the principal branch. So what is the arc sine of a half? So for arcs, this is another way of saying what is the sine inverse of a half. So I know sine, the two quadrants sine is in 1 and 4. So I have 1 and 4, and since this is a positive 1/2, I know I'm in the first quadrant because I'm positive. And sine, which is y, is a half for pi over 6. And what's the arc cosine of square root of 3 over 2? So this is also saying what is the cosine inverse of square root of 3 over 2? So what angle in the principal branch? So cosine, the two branches that we're talking about are in the first and the second quadrant. And since I'm positive, x is positive in the first quadrant, so I know I must be in this quadrant here. So cosine is the x-coordinate. So the x-coordinate is the square root of 3 over 2 at pi over 6. Okay, let's try 3 and 4. Sine inverse of negative square root of 3 over 2. So I'm talking about sine. So the two quadrants I'm talking about are the first and the fourth. So this is a negative. So I know I'm in the fourth quadrant. So sine is the y coordinate. So what is the sine? Where is the sine? The negative square root of 3 over 2. And that is at negative pi over 3. So this time I want to know what the rotation is of the angle in the negative direction. A lot of times we represent this in the positive direction, but this one I want to represent in the negative direction. Okay, tangent. So tangent is y divided by x. So the tangent inverse is the square root of negative square root of 3. So tangent is negative, or the two quadrants that we're talking about for tangent are the first and the fourth quadrant. And tangent is negative in the fourth quadrant, so I know my angle is here. And the tangent is negative square root of 3 at negative pi over 3. Okay. So we're just going to review some properties of inverse. So this is just like what we talked about in the earlier unit this year. When I have the function and the inverse, the answer is also always y equals x, because this is a reflection over the y equals x line, or the 45-degree line, now that we're working in the unit circle. So the sine and the arc sine, or I could say sine inverse of x. So when I have the function and the inverse, the result is always x. Or I could start with the inverse and the function results in x. And it has to do with, I'm reflecting over this y equals x line. And it doesn't matter whether I'm talking about sine, cosine, or tangent. So we've already covered this when I have my function and the inverse as a composition of each other. The result is x. And it doesn't matter if I have the function first or the inverse first. When I do a composite function with the two of them, they undo each other. All right, so let's try the next example. Okay, so I have tangent and arctangent of -5. So this is another way of saying tangent inverse of -5. So since I have the function and the inverse, they undo each other. So my solution is -5. Okay, let's do example 6. Arc sine of 5 pi divided by 3. So this is another way of saying sine inverse of sine. So sine, inverse, and sine. So I have the function and the inverse. The order doesn't matter. So now I want to make sure my answer is in the primary branch. So right now this is 5 pi over 3. So I'm looking at 3 over here. So here's 3 over 3. So 5 pi over 3. So this is going to be 1/3, 2/3, 3/3, 4/3. So here's 5 pi over 3. So this is telling me what the angle is in the positive direction. When I'm talking about sine, the two quadrants I'm talking about are 1 and 4. So I'm in the principal branch, but I want to name it in the negative direction. So this is -pi over 3. So I just want to name the angle in the principal branch. So when I do that, I name it in the shortest way from the x-axis. So these I name in the negative direction. Otherwise, I normally don't do that. Okay, so let's do these on the coordinate plane next. Okay, so next I'm going to talk about the cosine and the arc sine of -2/7. So since I have cosine and sine, these are not the same function. So the rules don't apply. So I'm going to do the work on the inside first. So this is saying the sine inverse of -2 divided by 7. So, and then I want to find the cosine of this angle. So the cosine of this angle is going to be x divided by r. But I don't know what x is. So right now I know sine is y divided by r. So I'll need to solve for x divided by r. So I want to know what x divided by r is. And then I know the relationship that I'm using the Pythagorean theorem because I'm on the coordinate plane. So I'm starting out by, I need to figure out which quadrant I'm in. So y is negative and r is positive. So for sine, I'm always talking about the first and the fourth quadrant. So I know my triangle is in the fourth quadrant, and I know y equals -2, and my radius equals 7. I need to find the x value so I can use that for my solution. So I'm going to start out with x squared plus y squared equals my radius squared. So x squared plus -2 quantity squared equals 7 squared. So x squared plus 4 equals 49. So I'm going to subtract 4 from both sides. So I get x squared equals 45. I want to take the square root of both sides. I want to undo the squaring. Oops. I need to simplify my radical with a perfect square. So this is going to be 9 times 5. So x is 3 times the square root of 5. So now I can find the cosine of theta, which is x divided by r. And we said x is 3 times the square root of 5, and the radius is 7. Okay, so we've done, I think this is the third time we've done these triangles on the coordinate grid. So we should be getting the hang of doing this. All right, so let's try one more similar example. So again, I'm starting by noticing that the sine and cosine, these are not the same. So I cannot just take this as my answer. So sine by definition is y divided by r, and cosine is x divided by r. So cosine is in the first and the second quadrant. So this is positive. So I know my triangle is in the first quadrant. So x is the square root of 3. R is 4. And I'm trying to solve for y because I need y for my solution. So x squared, the square root of 3 squared, plus y squared equals my radius squared, 4 squared. So 3 plus y squared equals 16. I'm going to subtract 3 from both sides, so y squared equals 13. I want to undo the squaring, so I'm going to take the square root. And 13 does not have any perfect squares, so it just stays as is. So I get y equals, oops, wrong green. Y equals the square root of 13. So substituting that in, I get the sine of theta is y divided by r. And y is the square root of 13, and r is 4. Okay, so calculator app. Okay, on our calculator, let's find theta, round to the nearest tenth of 1 radian. So since it's saying radians, I want to make sure my mode is in radians. Okay, so arc sine is sine inverse of negative 0.6412. So I'm saying second sine inverse, negative 0.6412, and what I see is negative 0.7, and I say radians, but I don't really write it, so I'm going to put it in parentheses, because radians we typically don't write. Okay, what is the arc cosine of 2? So this is cosine inverse of 2. So I'm going to type in my calculator, second cosine of 2, and I get an error. So an error means I'm undefined. So let's revisit, what does cosine look like? So cosine looks like this. So I go from -1 to 1, and this is asking me for some value here at 2. And 2 is not on my cosine curve. That's why it's undefined. All right, we are done.